Okay, so we're starting chapter 5, which is on analytic trigonometry, which really just means we're doing trig using algebra instead of relying heavily on the unit circle in SOHCAHTOA. So a lot of what we're doing is not difficult in individual steps, but all of it together seems overwhelming sometimes for students. So just make sure that you're paying attention and asking questions when you don't understand. All right, so today's lesson is not bad at all. We're going to start with some trig identities, just making sure that you remember some things we've already learned and learning a couple of new trig identities. So we have this paper that I'm giving them in class, and I'm giving it to them like on a pink sheet of paper. So if you want to wait until I give you yours to fill it out, you can, or you can print it because I attached it to the Google assignment. I'm going to be writing on here and on my own paper because I want you to see where some of these identities are coming from. All right, so if you have like glue and scissors and all that stuff at home, you can cut out the little number 5 tab and start your chapter 5 in your composition book. And then section 1 is on basic trig identities. All right, so to start with, we have learned quite a few. They're reciprocal identities we already know. We know that sine, so I would write these down even if you didn't print this paper. Make sure that you write them down and you know things, because you're going to have to, in the process of working problems this week, be able to replace something with another version of itself to be able to simplify things. So you need to remember that sine has a reciprocal of cosecant and vice versa. So we can replace cosecant with 1 over sine. We can replace sine with 1 over cosecant. If we see 1 over cosecant, we can call it sine. Cosine goes with secant. And tangent goes with cotangent. All right, so again, we're just putting all of the things that we know so far kind of neatly in one place. All right, the other ones that are easy that we all should remember are the quotient identities. So those are where we know that tangent is y over x in the unit circle, where y is sine and cosine is x, so tangent is sine over cosine. Sorry, my pencil worked. All right, and then cotangent is cosine over sine. All right, so some other ones that we need to know are even and odd properties. We learned this back in chapter 4. We said that sine is an odd function. So if I do sine of a negative angle, I get the opposite answer. So sine of 30 and sine of negative 30, one is 1/2 and the other is negative 1/2. With cosecant, since those are reciprocals, it's going to be the same. You can use x or theta anytime you're talking about a variable. It doesn't matter which one. If we're doing cosine, cosine is an even function. So if we do cosine of a negative, you get the same thing as if you did cosine of a positive. So like cosine of 30 is root 3 over 2, and cosine at negative 30 is also root 3 over 2. And then secant is its reciprocal, so it behaves the same. All right, and then tangent is an odd function. So tangent, we'll use 45 because that's easier. Tangent at 45 is 1. Tangent at negative 45 is negative 1, so the opposite. And then cotangent is its reciprocal, so it behaves the same. All right, good news is when you take your test over chapter 5, you will get to have this paper. More than likely, you're going to get to have all of your notes. I will almost 100% guarantee that your chapter 5 test is going to be open notes. You can use your composition book, so make sure you're taking good notes. Okay, so the co-functions, trying to think, I don't think we ever talked about co-functions in here, but we would have done that in chapter 4. And so co-functions and periodic properties are the same thing. So those properties look like this. So sine of pi over 2 minus an angle is equal to cosine. And if you stop and think, like pi over 2 is 90, right? And if you think about your sine and your cosine graphs, one of them is shifted 90 degrees from the other. And that is all that is saying. The same thing with cosecant and secant. All right, and then you can write it the other way. You can say that cosine, if we shift that, will give us sine. And again, you can use any variable you want for the angle in these, so it's kind of different. Each one of these formulas uses a different one. It doesn't matter. You can use x on every single one if you want. Let's see. We have tangent is a shift of cotangent. It's also like a reflection, but that's not gonna affect much. If you shift it right, it's not gonna matter. And I don't know why I put parentheses in some places and not in others, so whatever. These are not ones that we're going to use a whole lot at all. It's just so that you have all of them in a nice, neat little place. So don't worry so much about the periodic or the co-function ones. What we are absolutely going to use a lot are the reciprocal and the quotients, and those are the ones that people remember the most. These are not going to be used all that much. And then the other one that we're going to use a lot are the Pythagorean identities. All right, so to start with, when you took your unit circle test, we had the equation of the unit circle is x squared plus y squared equals 1. All right, so let me flip, I'll just write on the back of this, flip this over. So what I'm saying is on the unit circle, we said that x squared plus y squared is equal to 1. All right, because if you're on the unit circle, if I'm over here, then I have an x coordinate and a y coordinate, but we know the radius is 1. Okay, so using Pythagorean theorem, this squared plus this squared equals that squared. So x squared plus y squared equals 1 squared. Well, we know that x is cosine, so we can say cosine squared, and we know that y is the sine, so we can say sine squared. So cosine squared plus sine squared is equal to 1. We tend to write it the other way, but you can add in any order, right? So your basic Pythagorean identity is that sine squared plus cosine squared is equal to 1. Now keep in mind that that is the identity. But if you rearrange it so that sine squared is by itself, it would be sine squared is equal to 1 minus cosine squared. Or if you want cosine by itself, it would be cosine squared is equal to 1 minus sine squared. Those are all three the same equation. I just rearranged it, and a lot of times students need to have all of them sitting in front of their face because you don't remember that you can rearrange things. So I went ahead and wrote them all down. All right, so if I take this, and I'll go ahead and write it this way so that everything matches up. All right, if I take that and I divide the whole thing by sine squared, so I divide by sine squared here, and I divide by sine squared here, and I divide by sine squared here, then I get 1. I get cosine squared over sine squared, and if you look at your quotients identities, you should see that cosine divided by sine is cotangent. So cosine squared over sine squared would be cotangent squared. And then 1 over sine, looking at your reciprocal identities, is cosecant. So 1 over sine squared would be cosecant squared. So another form, or another Pythagorean identity, is 1 plus cotangent squared is equal to cosecant squared. Alright, so 1 plus cotangent squared is equal to, what did I just say? Cosecant squared. Secant squared. No, the co's go together. Sorry, I got distracted, so I'm going to just walk down the hall. Alright, so again, if I want to rearrange these, I could say that, if I move this over here, I could say that cosecant squared minus cotangent squared is equal to 1. Or if I wanted cotangent by itself, I could say cotangent squared is equal to cosecant squared minus 1. Alright, I'm going to run out of room because we've got one more. I'm going to try to squeeze it in there. Alright, so if I go back to my sine squared plus cosine squared is equal to 1. This time if I divide everybody by cosine squared, then we're going to have sine over cosine is tangent, so we'll have tangent squared plus 1 is equal to 1 over cosine is secant, so secant squared. Alright, so tangent squared plus 1 is equal to secant squared. That's your third Pythagorean identity. Tangent squared plus 1 is equal to secant squared. Alright, so if we try to rearrange that one, and I'm going to write it like sideways going up the side. So if we move tangent over there with secant, it would be secant squared minus tangent squared is equal to 1. And if we try to get tangent by itself, it would be tangent squared is equal to secant squared minus 1. Alright, so again, I need you to understand that that's really only 3 Pythagorean identities, but I rearranged it so that there's actually 9 ways that you can look at it. Okay, so now that we have all of our identities that we need to know right now, we'll get these other ones after Thanksgiving break. We're not going to get those right now. Alright, so let's see what we can do. And we're going to concentrate for the first part of today on using these Pythagorean identities. Alright, so what I need for you to be able to do is answer questions like this. Number 1. And keep in mind, sometimes I give you like stupid easy things, and you just have to recognize that that's what you're given. Sometimes they give you kind of hard things, and you've got to figure out how to handle them. Alright, so if I'm telling you secant of theta is 3/2, and I want you to find cosine of theta. Alright, well the first thing that you have to realize is that secant and cosine are reciprocals. So if secant is 3/2, that means cosine is 2/3, the end, no work. Alright, so what if I'm not so friendly? What if I give you one where they're not reciprocals? So let's say cosecant is 4/3. I want you to find tangent, and I'm going to tell you that theta is between 90 and 180. Okay, so the reason I'm telling you where to look is because different things have different signs in different quadrants. So if we're thinking between 90 and 180, we're in quadrant 2. And we know that tangent in quadrant 2 is a negative. Okay? Alright, so when I tell you what cosecant is, if we're using our Pythagorean identities, because that's the goal, is to use the Pythagorean identities, you could just draw a triangle, and I'll show you that, and when you take a test, I'm honestly not going to be that concerned which way you do it. But the Pythagorean identities are not that hard. So we have cosecant, and we need to get tangent. Well, if you look at your Pythagorean identities, we don't have cosecant and tangent together, we have cosecant and cotangent. But like we did up here, if I can figure out cotangent, I can just flip it over, and I'll know tangent. So we'll use one of the identities that has cosecant and cotangent. So we'll go with 1 plus cotangent squared is equal to cosecant squared. Alright, so plug in what you know. We do not know cotangent squared. We know cosecant is 4/3. So cosecant squared would be whatever 4/3 squared is. Because when they write this, they mean this times this. So if I have cosecant twice, I'm just multiplying times itself. The reason we put that little 2 in front of the x is because if you put behind the x, people get confused about whether you want the x to be squared or the function to be squared. Okay, so now this is a little bit of math, and I know fractions kill people, but they are not that difficult. All right, if I square the top, square the bottom, I get 16 over 9. All right, I need cotangent by itself, so we're going to subtract 1. Well, if I subtract 1, I've got to subtract 9 ninths, because 1 is the same thing as 9 ninths. So I get cotangent squared is equal to 7 ninths. All right, well, if I told you that x squared was equal to 7 ninths, you would just take the square root of both sides. So same thing's going to happen here. We're going to take the square root of both sides, and we will get regular cotangent of x. And that's going to be the square root of 7 over 3. I don't know the square root of 7, but I do know the square root of minus 3. I should put plus or minus on here, but I know that in this particular quadrant, tangent and cotangent are negative, so I just want the negative one. That's why I have to tell you the quadrant, otherwise you'd give me 2 answers. Okay? Alright, so if cotangent is negative 7/3, then we can say that tangent is negative 3 over the square root of 7, and then rationalize the denominator, bring it to the top, drop the box off the bottom, and you're done. Alright, I'm going to give you 2, one like this and one like this. So I want you to give them a try. So once I have them written down, I want you to pause the video, work them out, and then unpause the video and see how you did. Alright, so to start with, we're going to say sine theta is negative 3/4. Can you find cosecant theta? Number 4, if cosine of an angle is 3/5, can you find cosecant of that angle? And I'm going to tell you we are in quadrant 3. We are between 180 and 270. And I think I changed my, I did. I changed, like here, I changed my variable. Remember, x and theta are the same thing, so it's really cool. All right, pause, try, unpause to see how you did. Okay, so number 3, you simply just flip it, because they're reciprocals, sine and cosecant, so you have negative 4/3. All right, for number 4, they give you cosine. Your Pythagorean identity that has cosine in it also has sine in it, which is good because that's the reciprocal of cosecant. So you can use sine squared plus cosine squared is equal to 1. So we do not know sine squared. We know cosine is 3/5, so we can square that. So we get sine squared plus, what is that, 9/25 is equal to 1. So we're going to subtract 9/25 on both sides. In order for me to be able to subtract, I got to change this 1 to 25/25. So look, I gave you an easier one because yours works out with perfect squares, because that's going to be 16 over 25. So taking the square root of both sides, you should get plus or minus 4/5. But if we are in quadrant 3, we know that cosecant or sine in quadrant 3 is negative. So we want negative 4/5. Alright, so I said that I would show you how to do this with a triangle, so here we go. If we did this one with a triangle, we are in quadrant 3. We know that cosine is 3/5, so if I draw a triangle in quadrant 3 with the angle at the origin, we know that cosine is supposed to be negative 3/5, I would think, huh? It doesn't change anything though because you're going to square it first thing. But that should have been negative, which means this would be negative. But it doesn't change anything off the problem. So you'll have -3 here and 5 here, adjacent over hypotenuse. So Pythagorean theorem says that this would be 4, and because I'm in this quadrant, I know that it's -4. So then I can find the sign value. So again, if you use this method when you're taking your Chapter 5 test, I'm really okay with that. I just need you to be able to answer the question. Okay. Alright, so the next thing that we are going to do is, can you express a value of some angle as a value in quadrant 1? That literally made no sense. Let me write it down. Sometimes I try to reword things and it makes no sense. It says, express each value as a trig function of an angle in quadrant 1. Alright, so number 5, we have cosine of 600 degrees. Alright, so our first job is, do we know what cosine of 600 degrees is? Alright, so first of all, subtract 360 so that you're inside the unit circle. So we're really dealing with cosine of 240. Alright, 240 degrees is not in quadrant 1, but let's just think. Cosine at 240 is what? Okay, at this point, like, if you don't know your unit circle, then we are like cutting our losses. Okay, so if you just type in cosine of 240 in your calculator, you get -1/2. Okay, so what you do have to know enough about your unit circle is to know where is 240 in quadrant 1. So if it's -1/2, can you be -1/2 in quadrant 1? No. You can be +1/2 in quadrant 1. And your cosine value is +1/2 in quadrant 1 at 60 degrees. Now the good thing is 60 and 240 are reference angles. Okay, 240 is in quadrant 3 and it's 60 degrees away from the x-axis, so that's how you know this angle if you don't know your values on the unit circle. Alright, and since this is +1/2, we have to put a negative out front to make it the same value. Alright, so to recap, 240 is in the same place as 600. Those are coterminal angles. Cosine at 240 is -1/2. Okay, because that's the x-coordinate at 240. 240 is like right here. Alright, that is 60 degrees away from the x-axis. So if I come up here in quadrant 1 at 60 degrees, I should have the same value. I have that same 1/2 as my x value, but it's positive instead of negative, so I say that cosine of 240 is the same as negative cosine of 60. Alright, number 6. What about the sine of 390 degrees? Alright, so first of all, subtract 360 and see what we're dealing with. We are dealing with 30 degrees. So sine of 390 is literally the exact same thing as sine of 30 because they're in the same place. 30 degrees is in quadrant 1. No more thinking required there. Alright, number 7. You have sine of -410 degrees. I'm only going to ask you to do this with sines and cosines, by the way. Nothing too crazy difficult. Alright, so first of all, if we take -410 and we add 360, we are at -50. So add another 360 and we are at 310. So this is the same as sine of 310 degrees. Alright, 310 is obviously not in quadrant 1. 310 is somewhere in quadrant 4. Alright, sine is negative in quadrant 4. in quadrant y, and the sign is positive because it's the y. So we need to change the sign of the answer. So we're going to make it a negative sign of, and then this is a 50-degree angle, so it's going to be a 50-degree angle here. So sine of 310 is the opposite of sine of 50. So we write it as negative sine 50. Okay, so the next thing is, can we simplify? And this is what the majority, like the rest of this week, is going to be on. Can you simplify, and then can you verify? So simplify is I give you an expression and you try to simplify it down to make it smaller. Verify is I give you an expression, but I tell you what I want it to be equal to, and you have to take one side and make it look like the other using the same process as the simplify. All right, so that's what we're going to spend the rest of the week doing, because that's what causes people the most trouble. All right, so this is number 8. Okay, I was second guessing my problem, but this is our problem, sorry. All right, so we have sine x plus sine x cotangent squared x. All right, so our goal is, can we figure out some way to simplify this? All right, so my first thought always is change everything to sines and cosines and then work from there. All right, so the only thing here that is not a sine or a cosine is that cotangent. Well, I can change it to cosine squared over sine squared using one of those quotient identities. All right, so first of all, remember these are being multiplied. So the sine x is being multiplied by those, and it's like over a 1. And then this sine x is also over a 1, and it's being added. So when you have fractions, make everything look like a fraction. And then you have to do your can I simplify fractions bit. All right, and that is the most complicated thing for most people. All right, so you have sine plus, over here, you just have sine x cosine squared x over sine squared x. All right, so do you notice there's a sign on top and there's 2 signs on bottom? Ignore this one for now because you can't do anything with it because it's being added to the other one. But if you just look at what you have here, this sign can take one of these away. So this is really just cosine squared over sine, because this sign canceled one of those out because this means there's 2. All right, so over here, I need to get common denominators. So this is over 1, so I just need it to be over sine. Well, if I put a sign on the bottom, I got to put another sign on top. So I have sine squared over sine plus cosine squared over sine. Now that I have common denominators, I can write it as sine squared plus cosine squared. I know I don't always say the x when I'm saying it, but make sure you don't leave it off when you're writing it, because then you're writing something that makes no sense. All right, so now look at your Pythagorean identities, and you should see that sine squared plus cosine squared is just 1. So we can replace that with 1. So we have 1 over sine. And 1 over sine is cosecant, and that is simplify. All right, so simplify usually means get it down to where it just has one piece of trig. So it could be something squared, it could be something to the 4th, sometimes it's 1 plus something, but usually it's just one piece of trig when they tell you to simplify. That's what you're trying to whittle it down to. All right, so today the idea is that what choices I make sense. Should you be able to make those choices for yourself? Hopefully. But if you struggle with your assignment, that's really understandable. Do the best you can. And we will try to clean it up tomorrow. Or since you're at home, send me some specific questions. Send me what you did, and I can give you some feedback. I don't expect for it to be perfect. But make sure that you do show work, because otherwise I'm not going to give you credit for your homework. Okay, so here we go. Again, step 1, change everything to sines and cosines. So we can replace cosecant with 1 over sine. Leave cosine alone. Understand it's being multiplied by this cotangent, which we can call cosine over sine. Alright, so if we call this cosine squared over sine, this one actually already has common denominator, so we can just squish it to say 1 minus cosine squared over sine. Alright, so now look at your Pythagorean identities. Anytime you see 2 terms and either both of them are squared or it's a 1 and something squared, look at your Pythagoreans and see what you can find. It looks to me like 1 minus cosine squared is equal to sine squared. So I can replace that numerator with sine squared. And I have 2 sines on top and 1 on bottom. The one on bottom cancels one of them on top, and I just have sine. Alright, so next. At any time, if you think you want to pause and see what you can do on your own, that would be a great plan. Because they all basically start the same way. Change things to sines and cosines. So cosecant is 1 over sine. Cotangent is cosine over sine. If I told you to do 1/4 divided by 2/3, you know that would be 1/4 times 3/2. So that's really what we have going on here. We have a fraction divided by a fraction. So I can write it as 1 over sine times sine over cosine, because divide means multiply by the reciprocal. But now you see that we can cancel these guys and have 1 over cosine left. And 1 over cosine is secant. Alright, I'm going to work up here. Let's see if that works. Oh, you can see all of that. Alright, where are we on? Number 11. My numbers are off from yours, which is what made me confused a while ago. So, your number 11 is my number 12. Alright, so number 11 is cosine times cosecant times tangent. Alright, so step 1, change anything that's not a sine or a cosine to sines and cosines. So cosine gets to stay. Cosecant is 1 over sine. Tangent is sine over cosine. Alright, so you got a sine on the bottom and a sine on the top, they cancel. Remember, this is over 1, so you got a cosine on the top and a cosine on the bottom, they cancel. So you're left with 1 over 1, which is 1. Alright, last example for today. And you really should be able to, at this point, pause and see how you can do, because this one is pretty similar to one that we've already done today. Actually, it's kind of similar to 2 that we've done today. Alright, so here's our problem. Pause, try, unpause, let's see how you do. Alright, so cotangent. That's the only thing that's not sines and cosines. So we're going to leave cosine alone. Change cotangent to cosine over sine. Anybody that's not a fraction, remind yourself that they are fractions. Remember that you have to multiply before you can add. So multiply these two, and you get cosine squared over sine. To add fractions, you need common denominators. So I need this to have a sign, which means this gets another one. So the numerator is cosine squared plus sine squared, and that's all over sine. I kind of skipped showing this stuff there, just because we know this is cosine squared, this is sine squared, and we have the common denominator. So I went ahead and squished it and just wrote this as sine squared at the same time. Alright, so sine squared plus cosine squared is 1. And since you can add in any order, that works. And And then 1 over sine squared is cosecant. 1 over sine is cosecant, my fault. Alright, I know that that is not crystal clear. What I want is an honest attempt at your homework. Show your work, do your best, check your answers, see if you can figure out your mistakes. Send it to me and I will give you some feedback